Here is section 7.5 for college algebra. And we are going to be looking at systems of nonlinear equations. This was 7.6 in the newer textbook, but I changed it all around. So anyway, this is lesson 7.5. That's what you need to know. We are going to solve systems of nonlinear equations. So we're done with matrices, and we're just going to be doing some algebra and graphs again, and this is your last lesson. So first of all, we're going to use substitution to solve this system of equations. So you'll notice that now we have a quadratic there in the first equation and a linear in the second equation. So when I take a look at this and I want to solve it, I would need to pay attention. Like, I can't really solve that for x. I could solve it for y, and then I could plug that in here. I'm thinking about substitution here. We can't do elimination really because there's no x squared here that would eliminate. If there is an x squared in both equations, you could do elimination and just subtract them both down. For example, if I have x squared plus y squared equals 9 and x squared minus y squared equals 5, I could totally just subtract those, or actually let's just add them straight down, because when I add, the y squareds would go away, so I get 2y squared equals 4, and then we could finish solving this. You would end up getting some square roots in your answer. So y is plus or minus the square root of 2. So you have to plug both of those answers back in to find their pairs. Anyway, that is not this problem. So let's go ahead and solve this problem. So we have a line and a quadratic. I would say that this one's much easier, and you can choose whether you get x equals or y equals. Looks like x is pretty easy to get alone. So I'm just going to add y over to this side. So I have x equals -4 plus y. And this is going to be substitution. So I'm just going to take that and I'm going to put it everywhere there's an x in the other equation. So when I write that out, I get -4 plus y squared, because I'm putting it in that first spot, minus, and be careful, you're subtracting a bunch of stuff, so make sure you put parentheses for the second x, and then I have -3y equals 0. And now you can see when I substitute that in, my only letter left is y, so I need to solve this. We have a binomial squared here, so make sure you do -4 plus y times -4 plus y. If you know the shortcuts, you can do that, but take your time and don't skip steps. So we get 16 minus 8y plus y squared for this first term. And then we're going to do the minus and distribute the minus, so that's +4 minus y. And then just writing out the rest of the problem. Now I can put these in order. So there's a y squared there. I'm going to put that in the front. And then I'm going to combine all my y terms. So I have -8, -1, and -3, which is -12y. And then 16 plus 4 is 20. So I can solve this. This is a quadratic. There's lots of ways to solve quadratics, but we're going to try factoring because I'm guessing that's going to work. What multiplies by 20 and adds up to 12, -12, -10, and -2 looks good to me. So the solutions for y are y is 10 or y is 2. But I'm not done, because remember, when we solve one of these things, we need x and y pairs. So if y is 10, what would x be? So I can take that 10 and plug it back in up here. X is -4 plus 10, which is 6. So 6, 10 is one point where these two graphs would intersect if I was graphing them. And I can also take the 2 back up and plug that in. So -4 plus 2 is -2. So the x would be -2 when y is 2. So these 2 points are where the line and the parabola intersect. Remember, we have a parabola and a line, so there's probably 2 spots. It might only touch once, or there might be no intersection at all. So in this case, we ended up with 2 places. All right, for our next problem, we just have kind of a real world example. We've been doing this all year, but these haven't always been quadratic and things. But the supply is this first equation and the demand is here, and we want market equilibrium. We called it market equilibrium is when supply equals demand. So we're basically going to set these two equal to each other when the supply price in P equals. So they're both solved for P. I can just put this in there and solve this equation. So I have that set up on the next page. I just set them equal and solve. Now there's a Q squared, so I'm going to get everything on one side with the Q squared. So add 60Q over here and take 1200 minus the 804 to the other side. Or, sorry, we are going to subtract 1200. We're getting everything on one side because we have a quadratic. We're going to get negative 396 on this side. And from there, we can factor that. So 396 is a really big term. If you aren't sure what it's going to factor to be, you could always graph it since you can use calculators here, but we're looking for two numbers that multiply to be 396, and because this is a negative, subtract to be 60. If you graph it, you're looking for the zeros. So really quick graphing it, I can see that one of the zeros is 6 on my graph. So that means, what is 396 divided by 6? It's 66. So if I made this a plus and this a minus, then that would add up to 60 and multiply to be 396. So I'm just kind of using the graph to kind of help me find these factors. So Q equals 6 or Q equals negative 66. Now, negative 66 is not going to be a reasonable answer for a quantity of a product. So Q would be 6, and then we can go back to the original equations and plug a 6 in here. So if you put 6 in here, you should get the same answer in both. So if you want to make sure you're right, you can put a 6 in the first equation and a 6 in the second equation and just double check. They both equal 840. So what that means is that for market equilibrium, the supply price would be 840 and the quantity would be 6. So these are expensive items. And that concludes that question. So here's another one. We're going to solve this system, and this time we're going to do it on the graphing calculator. So again, we have a parabola and we have a line. The parabola is already solved for y equals, so we would put this in y1, and this one we would need to solve for y equals, so we would just subtract that 2x over, and you can put negative 2x plus 4 or 4 minus 2x. So put first equation in y1, y2, and press graph, and you should see the two equations here. And now what we're looking for is the solution. Well, the solution is or are the points where they intersect, and there are 2 for this problem. So all I need to do now is find those 2 solutions. You can probably tell this one's probably 2, 0, but that one we might need to check. So you can use your second trace or second calculate the intersect feature. So you press second trace, which is up on the bottom there, top, sorry. And then you're going to look for the intersect, which on my calculator is number 5. And you go to the left and hit enter, and the right and hit enter. You can be below or above. It doesn't really matter as long as you're left first and then right. And then if you want to find the other one, you would want to surround this one on the left and the right. It doesn't matter which graph you're on. When you do that, your intersections are, it's not 2, 0, negative 2, 8. So this one up here is negative 2, 8. And I did them backwards. And this one is 2, 0. I did the left one first, but that's okay. And that's all you have to do. So use your calculators to graph, and have a lovely day.